What's up, guys? Let's take a look at another CodeWars exercise. This one's called Pair of Gloves, and I love it because at first it seemed so hard. I was considering all different approaches, and none of them were that perfect until I realized there is one way that works, and it's actually pretty easy. So how did I get there? Well, this is about a drawer full of gloves, and we're looking for pairs. So if we have 2 reds in there, that's a pair. If we have 2 blues in there, that's a pair. It doesn't matter what order, and there's no left or right gloves that have to match. It's just any 2 reds or any 2 of a match. And it's not just 2. If you have 6 reds, well, that's 3 pairs of red. So when I started this, I thought, okay, how do we find a pair? We're on a red and we find another red somewhere on the list. Do we remove them so that we don't catch them again? Or do we make a new list that has them skipped? Or do we mark down the index? I don't know. Then I thought, oh, maybe we'll put them into a string. Maybe we'll, like, you know, join them into a string, and we'll make it sorted. You know, imagine we do that so that they would be next to each other, and then we can use the replace method. We could say, like, oh, red, red, well, we replace red, red with nothing, and that's the replace method, and we add to a counter, and then we replace blue, blue, we add to a counter, and then we see how many times. You wrap that in a while loop, and then you figure out how to see if it's done. It would have been a mess. It would have worked, but it would have been a mess. And since it was a mess, I thought of other ways. I thought, all right, what if we make a recursive function, which is a function that calls itself? This one would just remove a single pair, and then it would call number of pairs of, like, the new gloves, like the new version that we've removed one from. And so it would call itself, removing a single pair each time, until it found that it couldn't, and then it zoomed all the way back to the beginning with some kind of count. I had this idea of, like, adding a hidden extra parameter that was, like, optional, and then that would have worked. That would have been fine, but it's way too much, way too long. Instead, I realized we don't have to change the list. We don't have to rearrange it. We just have to count. Okay, we just have to see how many reds are there. If it's 2, that's a pair. If it's 6, that's 3. If it's 7, that's still 3, because we're just dividing and taking no remainders, right? So we can do a counter, and this is something I've talked about recently. We had a CodeWars exercise about counting words in a sentence, like how many times do they appear, or how many times does the letter E appear, and that was fun, but there's a built-in way in Python to do that. It's called counter. If you say from collections import counter, and it is a capital C, then we could do a counter of gloves, and I'll just print that to show you what it is. It's a dictionary, or a very dictionary-like object that brings up each item, tells you how many times. So then we can just divide it by 2, again, no remainder, just the integer, and we can see, oh, well, that would be 1, and if we had some bigger number like 13, that would be 6, and we just add them up. So we can do, you know, count, whatever we want to call it. Let's call it, actually, let's call it value, because we're going to go through. If you remember, whenever I loop through a dictionary, I usually go .items, because that's both sides, that's the key and the value. But if we don't care about the key, it doesn't say how many pair and what color are they. It's just how many pair. So we don't care about the keys, we just want the values. So we can call it value, or just V, you know, V over 2 for V and that. And then we sum, because we're adding up the total pair. So if there's one that has like 5, then that's 2, and there's another that has 2, then that's another 1. And then we return that whole thing. So that's perfect. It's 1,000 times simpler than what I had originally done. And then turns out everybody else thought of that too. So I wasn't special. I thought maybe there would be some people who had struggled with it, and of course there are if you scroll down long enough, but by far the majority said, hey, I'm going to use the counter and divide by 2, or I'm just going to use the count method on each one. The way they avoided duplicates, if you see a red, you get the count, and then later you see another red, is they looped through the set. The set is unique elements. A set has nothing to do with order, nothing to do with how many. It's just one question, is it in there or not? And so if we take the set, that's basically like keys in a dictionary, because they're also unique. And, well, I was going to say they're also unordered. They used to be unordered. Dictionaries in recent versions of Python have an order. So this person did exactly what I did. This one did pretty much the same thing. This one made a specific name for the set, but otherwise absolutely the same idea. I think this is slightly less efficient because you might be counting for like multiple passes through, like you have to look through the set and then look through it again, whereas counter just goes through once and keeps track of all of them. But it's, microseconds longer. It's not a big deal. This person kind of did the same thing, just hand rolled their own instead of using the counter and going with that. It's fun to do once if you do that, and that's exactly what we did in that one Unit 9 project I was talking about. But afterwards you just say, hey, you do the work, Python, tell me the counts. And that's pretty much it. We can see a few slight differences, but they're all based on the idea of count /2, which is not messing with the list, not doing recursion, not doing anything fancy. And I'm so happy about this one, because I sat there for 5 minutes thinking, how am I going to do it, until I realized, and then I saw that I wasn't alone. Everybody else had the same thought process, or at least the same end of the thought process. Maybe they skipped some of the anguish that I had. And that's really fun whenever you have a problem that seems tough and then you have the eureka moment with the light bulb above your head. You're in good shape.